Three more examples of integration. So we're going to go ahead and solve these. Here we have an exponent that has a function. That's a function. Most of the questions we've dealt with have functions that have constant exponents. Here we have a constant with a function as the exponent. So we're going to say u is the exponent. So that's 4x squared plus 5. The derivative then is 8x dx. And we can make that substitution because we have an x dx. We can divide by 8 here. Du over 8 is x dx. So we remove the 3, we divide by 8, integral inside, x dx becomes u, and we're left with 6 to the u du. And this is an integral that we can remember the rule for. So the integral of 6 to the u is 6 to the u divided by the natural log of 6 plus a constant, and now we simply replace the u. So 3 times 6 to the 4x squared plus 5 over 8 ln 6 plus a constant. The next example is a little more confusing because typically we want to set u equal to the part here in brackets and hope that du is the part that's left over, but in this case the power in the brackets is 3, outside we have 5, so it's not going to be the part that's left over because when we take the derivative here it reduces the power. But we can use the same idea. So we'll start by saying yes, let us try to make u equal to x cubed minus 3. And du gives us 3x squared dx, and if we divide by 3 then we get x squared dx. So we can get rid of x squared dx, but that leaves us x cubed left over. So let's see what we can do with that. We're going to rewrite this as the integral of x cubed times x cubed minus 3 to the power of 3 over 2. Now I only wrote 3 of the x's here, we have 2 left over, so I'm going to stick those at the end here as x squared dx. So we have the integral, the x5 is here, just separated into 2 pieces with this in the middle. Now what we can see is this part here is du, or du over 3 in this case. So let me just highlight that for you. This part here is this. Well, what that means is we somehow need to get rid of this x cubed, and we can make the u substitution. And if we look here, we have an x cubed. So what we can do is solve this and say, in this case, x cubed has to be u plus 3. Bring the 3 over here. So this is x cubed. So we can write x cubed as u plus 3. X cubed minus 3 we know is u. That's what we chose. And this here is du over 3. That changes all of our x's to u's. And what we get then is 1 over 3 times the integral of u plus 3. That's our x cubed. X cubed minus 3 is u to the power of 3 over 2. X squared dx is du over 3. The over 3 is out here, so that's just du. Now what makes this easier to solve than this question, you ask? Well, here we had a binomial with a power. Here we have a monomial with a power. So in this case, we can multiply in the u. And that gives us u to the 5 over 2 plus 3 u to the 3 over 2 du. One more step then. We can now integrate, so we get 1 over 3 u to the 7 over 2 over 7 over 2 plus 1 over 3 times 3 u to the 5 over 2 over 5 over 2, all plus a constant, leaving 2 to u to the 7 over 2 over 21. 2 comes up, 3 times 7 is 21. plus 1 over 3 and 3 are canceling here. So 2u to the 5 over 2 over 5 plus a constant. Of course, our question doesn't have u, it has x. So 2u is x cubed minus 3, 7 over 2 all over 21, plus 2 x cubed minus 3 to the 5 over 2 over 5 plus a constant. And so that's the final answer. A longer question, but using the exact same idea as the question before with that one extra step up here where we solved for the x cubed. This last example then is going to be very similar in how it works. So let's have a look at that. U is going to be our denominator here. Then du is going to be dx. So we can replace dx with du. X minus 8 is u, but we have this x left over in the numerator. Well, how do we get rid of an x? We solve this for x. So this is x equals u plus 8. Now why does that help? Well, if we make the substitution now, we'll take the 4 out. The numerator becomes u plus 8, because the 4 is outside. The denominator is u to the power of 3, and dx is du. Now we don't have a binomial in the denominator anymore, we have a monomial, which means we can write it as the integral of 1 over u squared, which is u over u cubed, plus 8 over u cubed du. And now we can integrate each piece by itself. So we get a 4, u to the minus 2 is what this would be, so that becomes u to the minus 1 over minus 1, plus 4 times 8 is 32, u to the minus 3 becomes u to the minus 2 over minus 2, plus a constant. Now we'll simplify and replace u with x minus 8, and that leaves us negative 4 over x minus 8 minus 16, 32 divided by 2, and the minus comes out front, over x minus 8 to the power of 2, plus a constant.